on various so 3 of my analysis of the fallout here in the UK, which was sampled and taken on the 7th of September 2023. All of the analysis was carried out using X-ray fluorescence. And I'm just going through now a baseline comparison with peer-reviewed papers that are already out there on sand dunes from Sahara and also from atmospheric dust from the same area. So effectively from North Africa all the way down through to Middle East and further. So that's what we're doing. I wanted baseline data that was out there that was quantified, and that's what I've used. So what I'm going to do now is look at the elements. So these are the individual elements rather than the oxides of those. And this time we're going to compare the UK fallout with atmospheric dust collection. Atmospheric dust collection in this particular case was actually analysed and collected in Shiraz in Iran. So that region has a lot of problems with atmospheric dust and sandstorms, so that's why I chose it. Very good comparison, and bearing in mind that's a lot closer to where the native sand is compared to the UK, which is in the Northern Hemisphere. So again, let's run through these. So aluminium, again, lots of people go, oh, aluminium. So aluminium, if we look at what we have in atmospheric dust from Iran, we've got 67,200 ppm. If we look at the UK sample, we've got 20,442. That's very high, but it's a natural occurrence. Then we look at calcium. Again, we've got 77,000 parts per million in atmospheric space dust, and what fell in the UK was 104,000 parts per million. So significant increase. And then we go on to magnesium. Magnesium, we had none in the UK fallout, but it's naturally normally in atmospheric dust. So atmospheric dust in Iran, 19,600 parts per million, below limit of detection here in the UK. And then we go potassium. Potassium, we've got 15,000 parts per million in atmospheric dust, and we've got 25,000 parts per million in what fell in the UK. Titanium, we've got very similar results. We've got 5,100 in atmospheric dust, and we've got 7,200 in what fell here in the UK. Arsenic, very interesting. So arsenic, very low in atmospheric dust, 4.5 ppm. However, in the fallout in the UK, we had 44.9 ppm. And then we've got cadmium. Cadmium hardly shows in atmospheric space dust. However, with the sample taken in the UK, we'd got 15.7 actually ppm of cadmium. And then we'll just move along. Cobalt, normally in atmospheric dust, had no cobalt in the UK fallout, below level of detection. Chromium, I mentioned chromium in the oxides. Chromium, again, very interesting anomaly we've got here. 98 parts per million normally in atmospheric dust, yet in the UK sample we've got 454 parts per million. And then we've got, then we start to go into some interesting things. So we've got things like molybdenum. Now, again, molybdenum, 0.79 ppm, so not really a comparison when you look at the very high ppms that we've been talking about. Yet when we analysed what fell in the UK, we got 14.66 ppm. And then we've got nickel. So nickel, 68 ppm in atmospheric dust and 217 in the sample from the fallout here in the UK. Lead, 30 ppm normally in atmospheric dust, yet what fell in the UK was 114. Now a lot of that can be put down to local pollution. I live very close to the M6, so that could have been part of the fallout. So I'm not suggesting that they're dropping lead on us. I'm just saying that the lead may be as a result of me being close to cities and also a major highway here in the UK. And then we go into things that are quite interesting. So we start to look at things like strontium and vanadium and zinc. I mean, these are again always found in atmospheric dust. And you might think, oh, really? Yes, they are. Again, numbers, strontium, almost identical. 287 in atmospheric dust, 271 in the UK sample. Vanadium, 102 in atmospheric dust, and 273 here in the UK sample. Zinc, 106 in atmospheric, and then 764 in the UK. Extremely high on the zinc side compared to what should be in atmospheric dust. So, you know, this is all the data. It's all here. I've literally got everything that I did. All samples, by the way, are tested 4 times, and then they're averaged out, and we take a mean from that. So we do the same sample 4 times under each setting, and then we take the average of those. So that's what I've done. So I'm giving you the average rather than the individual readings. So what's my conclusion? My conclusion is that it's a little bit misleading what they said in the mainstream media. You definitely can't say this was Sahara sand. However, it's very much in the same baseline, and I would say it's very close to a fingerprint of what we know as atmospheric dust from a region which has a large body of sand dunes. So atmospheric dust, pretty much the same all over the world. I've taken baseline data that is really direct from source. So these are really high elevated numbers, yet what we have here in the UK, we've got certain elements that are much higher than I would expect to see. But it does follow that this was an atmospheric dust. However, and this is the interesting thing, I think inadvertently what happened when all of this stuff just dropped in the UK because of rainfall in the early hours of yesterday morning was that it brought down a lot of other things that maybe shouldn't have been in the atmosphere in the first place and are definitely being put there by some other means. And that's the stuff I really want to go into in another post. But to cover off what the media was saying and what I have found using X-ray fluorescent analysis of the actual sample is that this is very much in line with atmospheric dust. However, there's a lot of things in there that shouldn't be there, which I will discuss in another post. But right now, I just want to compare like for like. So I'm not going to talk about elements that I do not have corresponding data to in published papers. Hopefully that makes sense. So thanks for watching. Hope it's been of interest. I'll put the graphs up so you can see the data yourself. Yeah, vibrations up, live life, and love nature. Thanks, folks.